Hi, I'm Serena Anand-Chancellor. I'm a NASA astronaut, and this is Ask NASA, and I'm ready for your questions. All right, so first question. What is Artemis, or what is the Artemis program? So the Artemis program is our lunar exploration program. We will get to the South Pole of the Moon by 2024, landing the first American woman and the next man. Why are we doing this? Well, in order for us to head towards Mars, we need a special place where we can practice, essentially develop robust engineering technologies, figure out how well the human does with long-duration spaceflight, learn how to build habitats, and we do all of this on the moon. Essentially, we practice. It's an engineering battleground, so we can go to Mars. What do you think it'll be like to go on an Artemis flight? Well, let me tell you, this would actually be really cool to go on an Artemis flight because we'd be heading to the moon. Now, what vehicle will we be traveling in? Well, it's actually the Orion vehicle right here. And some of you may recognize this. This is similar to the old Apollo capsules, but it is bigger, it is better. I've actually climbed inside the mock-ups, seen the systems, very modern systems. This is what will be taking us back to the moon. It's gonna have the first American woman on the moon.
Serena, did you always want to be an astronaut?
I did, probably since I was 8 years old. My dad finally asked me one day, do you want to be an astronaut? And I said, yes.
What one personal item did you take to space?
Oh, I took multiple personal items. It wasn't just one. Funny enough, I took a back scratcher because you need a back scratcher wherever you go.
What food would you take to the moon?
Oh, easy. Cheeseburger, French fries, every time.
Yum. If you were in a dance-off with an alien, what song would you pick?
That's easy. It'd be Michael Jackson's Billie Jean. We played this song on the launch pad.
What do you miss the most about Earth when you're in space?
I missed feeling the Earth. So I miss the wind, I miss the rain, I miss the smell of the Earth, the smell of the grass. These are things you just can't imitate on station.
Is it scary being in space?
It's not scary being in space. I mean, it's your home, and it's the size of a 5-bedroom house. It's absolutely huge, and your friends are up there with you, so what's better than that?
Do you know how cool you are? Because we think you're amazing.
You know, as my husband says, I still take out the trash like everyone else.
So you're a doctor. Can you fix this man?
Well, I'm an internist, not a surgeon, but I will try. Ooh, I've got to do this carefully. I don't want to set off. Yes. Yes, see, so now. Nope, that's it.
Do you have a question for NASA? Send your questions to our experts on Twitter using hashtag AskNASA.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
we need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources,
we're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
At NASA, we have always answered the innate call to go. With Artemis,
we are going to stay.
Proving that humanity
Can live on the moon
Mars,
and other worlds.
and share the wonders of the solar system with all.
Our story is one of people.
All those who make this journey possible.
From advocates across communities,
To companies across industries, to countries around the world.
we achieve
This collective endeavor.
our efforts create impact for all.
Technologies that revolutionize industries.
And jobs that bring prosperity to people.
The discoveries from space
benefit the way we live on Earth today.
And those from the moon
will create a better future
for generations to come. But to do that,
We must go.
hi, I'm Chell Lindgren. My name is Raja Chari.
Kayla Barron.
Kate Rubens.
Hi, I'm Christina Cook.
NASA astronaut Joe Akaba.
Jessica Amir,
Woody Hoberg.
Anne McLean,
Stephanie Wilson,
My name is Johnny Kim.
Nicole Mann,
Victor Glover.
Jessica Watkins.
Hi, I'm Matthew Dominic.
Jasmine Mogbelli.
Frank Rubio.
Scott Tingle.
this is what we do. This is what we will do.
Let's go.
We go to the moon to learn how to live on other planets.
For the benefit of all.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
"50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go. We go as the Artemis generation.
We go.
Three, 2, 1, 0. Ignition. Liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the surface module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
We're going to the moon to explore, and we're going to the moon for scientific discovery.
Our destiny is always to go and see what's further and what's next.
The moon is a stepping stone, and the moon is a place we need to learn how to live so that we can continue to go beyond.
We are focused. We are focused on all that lies before us. Only together will we bring to life this global ambition of returning to the moon. And while our work is far from finished, we've never been closer to seeing a new generation step beyond our home planet. We are building on the achievements of those who came before. The giants who conquered gravity and raised a banner in the heavens, they beckon us to go farther, to the moon and on to Mars, to seek a deeper understanding of our universe and bring all that we learn home. 2020 was a year of unpredictable hardships, and yet, step by step, we resolve to press forward toward this grand vision. The daily efforts of thousands of suppliers from all across this country and around the world fed into stunning milestones and laid the groundwork for history.
Launch team, go.
Artemis has been woven into our culture. It has fostered collaboration across the aisles and across the ponds. It has grown beyond plans and preparations to include hardware and software. And now, it has a heartbeat. You can feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way.
Our mission to the moon is no longer some far-fetched dream. This is reality. We are going.
This is the next step in evolution.
They're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use.
This is real. This is going to happen. We're going.
We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
On the hottest planet in the solar system, a probe descends through a thick, poisonous atmosphere. It is both a time capsule and time machine, unlocking secrets of the ancient past, while revealing how a world can turn from possibly habitable to horrible. The location? Venus. Our sister planet has much to tell us about our own and exoplanets, helping ignite a scientific renaissance for our universe. The mission, brought to you by NASA Goddard and its partners, is aptly named DaVinci Plus, the first U.S. probe mission to Venus in over 40 years. With the probe acting as chemistry lab and photographer, other cameras will map and gather additional views of the planet from above, providing a new study of Venus that has scientific implications well beyond our own solar system. DaVinci Plus will give us a new understanding of planetary evolution. Launching in 2029, 3 years will be spent exploring our celestial neighbor. DaVinci Plus, coming soon to a planet near you.
The importance of landing humans back on the moon is we're going back in a way that is totally different. We've had almost 60 years of experience, and we're taking every single ounce of experience we have and taking that with our international partners, with our commercial partners.
We've been working for the last year with 3 partners who will help us achieve the next human mission to the moon. Because we know that this first step to the moon will then lead us to go to Mars. And we know that the human landing system is one of the first steps to get us there. And so we've been working with Dynetics, Alido's company. We've been working with Blue Origin, who have partners of Draper, Lockheed Martin, and Northrop Grumman. In addition, we've also been working with SpaceX.
This is a very, very exciting time for the Human Landing System program. They've spent a lot of blood, sweat, and tears over this last couple years getting ready for this moment.
We're really excited to bring you the announcement of who NASA is going to continue to finish out the human landing system and take humans back to the moon. NASA has chosen SpaceX to return us to the moon. I am so excited to partner with SpaceX in this fantastic endeavor for the Artemis suite of missions. So congratulations to the SpaceX team.
The SpaceX design is a single-stage solution using their Starship. It provides extensive volume for the crew with 2 airlocks and ample down mass capability. The SpaceX proposal included in-space propellant transfer demonstration and uncrewed test landing.
So now that we've selected our partner, and for the next phase going forward, we have to make sure that the testing occurs, because we're not going to launch humans until we have a successful test. So we will be working to make sure that the design and everything that we have going forward so far is ready to go.
So the human landing system is going to allow us to be able to access different parts of the lunar surface. But it also allows us to explore a new technology and capabilities that will help us when we are trying to figure out our next round of technologies to be able to help us land on Mars or other planets out there.
I'd like to thank the companies for the great work this past year. We've all learned a lot. I'd like to thank the NASA team, because you have definitely risen to this challenge.
It is one more step and an exciting group of steps that will get us to a sustainable human landing system to the moon.